All right, so next up, we're going to talk about rate laws. This is a very important concept and something we're going to spend a lot of time on and that you should be very comfortable with. So what rate laws do is that they describe the relationship between the concentration and the rate. So for example, what I mean by this is if I double the amount of A, say A is a reactant, what happens to the rate? Does the rate double? Does it not increase? Does it decrease? Does it quadruple? What does it do? And so let's take a look at an example. So we have AA plus B going to, we'll just say products. So when we're talking about rate laws, generally we're just talking about the concentration of the reactants, although sometimes the products do show up in the rate law. Remember, the lowercase letters are just the coefficient numbers. The big letters are symbols of elements or compounds. And so you need to be very comfortable writing rate law equations. And it's overall not very simple. So what you do is you always say the rate. So you always write out rate. And then you say the rate is equal to K. It's always going to be K. And then times the concentration of all of your reactants. So the concentration of A to some exponent. So we'll just call this M. It doesn't matter what letter you can use. You can use X, Y, Z, whatever the heck you want to use, times the concentration of the other reactant up to the N, right? So it's rate equals K times the concentration of your reactants up to some unknown exponent. And so let's take a look at the different components. So the rate is obviously how fast your reaction is going. K is what's known as the rate constant. The rate constant. And so the rate constant depends on which reaction you're talking about, as well as the temperature. So different reactions will have different rate constants, and reactions at different temperatures will also have different rate constants. Concentration of A and B is pretty self-explanatory, right? That's the concentration of A and B, your reactants. And then we have these exponents, this up to the M and to the N. This is what's known as the reaction orders, the reaction orders. And these are determined experimentally only. Many times they will match the coefficients in your equations, but that's not always true. These numbers can be anything. They can be negative numbers, they can be positive numbers, they can be fractions, they can be whole numbers, but the vast majority of times they're whole numbers, and the vast majority of times they're either 0, 1, or 2. So let's take a look at the most common things, right? So if M or N is equal to 0, we say that it is 0 order in A/B, right? So if M is 0, if this M up here is 0, we say the reaction is 0 order in A. And I'm going to do these little this kind of parentheses thing that just means copy down what was written up above. So if it's equal to 1, then we say it's first order in whatever the heck you're talking about, right? So if this M is 1, then the reaction is first order in A. Again, you just kind of want to copy this stuff down. If it's 2, then we say that it's second order in whatever the heck you're talking about, right? So let's take a look at the examples. And then one more thing to note here is that the overall reaction rate is the sum of the exponents. Right, so you can be kind of first, second order in different components, and then you have an overall order of the reaction. So let's just take a look at some examples real quick. So here we'll say for one of these reactions, rate is equal to K times the concentration of C4H6 squared. And so here we say that this reaction is second order in C4H6, and it's a second order reaction, right? So it's the same because its rate is only dependent on one of its reactants. In another example, we have rate is equal to K times the concentration of H plus times the concentration of OH minus. And so we can say that it is first order in H plus and OH minus, right? I don't have an exponent here. When you don't see an exponent here, there's an imaginary 1 there, right? It's just redundant, so we don't show it. So we can say it's first order in H plus and OH minus, and then the reaction overall is second order because it's a sum of the two ones. Right, so first order in H plus and OH minus, second order overall. So be very comfortable writing rate laws. And so for now, you can just leave these kind of variables for your exponents, and later on we'll learn how to determine what these variables are.